Hi, it's Alan from Crashtest Security. I will tell you more about microservices security best practices in this video. So let's get started. A microservice architecture, often referred to as microservices, is a set of group services to implement an application. Lately, development teams prefer microservices. Why? It facilitates continuous delivery for large applications and adapts easily to the organization's needs as its technology evolves and scales up with minimal effort. Monolithic applications are a single-tier structure, making it easier to stand up quickly, and they integrate reliably with well-known integrated development environments, IDEs, frameworks, and tools. The image in the video displays a typical application broken down into a set of microservices. These services are essentially miniature applications hosted on individual containers while communicating through a service proxy. Any external entity, depicted in green, be it a user or an external service, would access the application through a secured API gateway as a whole rather than an individual microservice. Advantages of microservices. While DevOps eliminate organizational silos by enabling efficient collaboration, streamlining workflow integration, and automating application delivery, microservice architecture is essential for achieving a DevOps model by distributing an application into multiple deployable services. Microservices work as autonomous applications, decoupled from each other, built, scaled, and deployed independently. This lets teams comprehend the application architecture easily and speed up delivery pipelines. As engineers adapt to modern applications, they take with their intimate knowledge of the interdependencies of applications. This makes it very difficult to move the development forward at the pace required by the organization. By segmenting the application's functions in a microservice architecture, engineers can easily understand the structure and enhance the speed, meaning they can move quickly to continue development. So, the benefits of a microservices-based DevOps model are a dime a dozen. But then, there are challenges in maintaining a microservice architecture and explicitly dealing with elaborate security implementation. Microservices and security. Microservices are considered to be 4 times more vulnerable than traditional monolithic applications. In addition, due to its distributed structure, each service API and network layer expose susceptible entry points to potential attack vectors. Microservices are uniquely orchestrated using a broad range of tools compared to a monolithic framework. Usually such tools rely on pre-built repositories, open-source code, and containers without validated security protocols. Implementing a security strategy gets complicated with the extensive usage of third-party unpatched libraries within each container, increasing overall risk. Additionally, as microservices are containerized applications in their core, a single compromised container enables attack vectors to replicate the hack across a wider surface quickly. With security being a constant challenge for organizations switching to microservices, a cultural shift and a new mindset are necessary foundations for a functioning security strategy. Security, operations, and development personnel must cooperate across functions in a DevSecOps arrangement that prevents security from getting laid back to develop new capabilities. Instead, teams can use security principles to build their code and have it peer-reviewed for security concerns before deployment. Additionally, monitoring microservices is considered critical in maintaining security within a microservice framework. The absence of efficient load balancing and application monitoring worsens an organization's combat position in isolating threats and negating a quick quarantine. Therefore, effective monitoring for microservices is crucial to be administered across all layers, including API payload, query strings, cookies, and HTTP headers. Typically, service calls are secured by implementing an API gateway, which acts as the single entry point to receive calls and route traffic onto different services. This approach of having a single entry point through authentication has its own merits and demerits. Theoretically, an API gateway limits the attack surface. However, it also turns out to be a single point of failure for potential attack vectors. Recent research also suggests that most traditional attack vectors target an application through API calls. Source: https://docs.microsoft.com. These gateways typically handle authorization and authentication for the microservices to ensure that users are who they claim to be and are allowed access to a service. To keep their efficiency, security teams need to restructure the security models to keep an adversary's security in front of the API gateway without forgetting attackers that target a single microservice. How to secure your microservices. The approach to enabling secured access to microservices remains substantially different from a traditional monolithic framework. As a rule of thumb, administering secure authentication by provisioning on-demand identity tokens remains crucial. Short-lived encrypted access secrets are distributed through a zero-trust strategy to pass the right authorization level on an application, service, or pipeline layer. With an increase in the application's attack surface, a cross-platform centralized security module doesn't hold ground. Securing microservices is usually considered ineffective and insufficient to limit application threats through only a network segmentation or a perimeter-based approach. Instead, securing microservices starts with the holistic approach of embedding security by transforming DevOps into a DevSecOps model. This begins with the mindset of considering security at par with development and operations since the beginning of the SDLC, by essentially analyzing risk tolerance from day one of a software lifecycle. With a DevSecOps model in place, performance, scalability, and security are weighed equally without bias. Of course, there are also several architectural considerations for deploying a secure microservices model, which is explained below. Microservices authorization best practices. Securing access points with Auth2 and OpenID Connect. Many security analysts do not prefer starting from scratch and recommend using Auth2 and OpenID Connect to delegate authorization management to a third party or a single, internal authentication service. In addition, using libraries and functions can shorten the development time and make it easier. Several solutions for improving the security level of your Auth-based authorization service have already been built by some of the biggest companies and brightest engineers around. Use defense in depth. Defense in depth is defined as an information assurance concept in which multiple layers of security controls, defense, are placed throughout an information technology system. You need to identify your most sensitive services and manually apply many different security layers to them to get more challenging for a potential attacker who can exploit one of your security layers. Microservices architecture makes it easier to adopt this strategy microscopically and strategically by focusing your security efforts and resources on specific microservices. In addition, the architecture diversifies the layers of security you wish to adopt on each microservice. By this, an attacker who can exploit one of your services may not necessarily be able to figure out how to exploit the second one. Don't write your crypto code. It is advised that when it comes to security, you shouldn't try to roll your new solutions and algorithms unless you've got solid and specific reasons to, and you've got people skilled enough to create something nearly as good as the open source tools already available. Get your containers out of the public network. An API gateway establishes a single entry point for all requests coming from all clients. It subsequently knows how to provide an interface for all of your microservices. Using this technique, you can secure all of your microservices behind a firewall, allowing the API gateway to handle external requests and then talk to the microservices behind the firewall. Our automated testing suite can include periodic vulnerability and security scanning for your containers. For example, we could prove a comparatively better scan depth on the client systems. You can check out our product and its features and try a free 14-day trial here. Continuous security. The best solution for microservices security is continuous security that is as flexible and agile as your development. Continuous hacking adjoins continuous integration and continuous delivery with source control monitoring and dependency scanning to ensure CI/CD pipelines are tested during execution for runtime checks. A common practice is employing static application security testing, SAST, and dynamic application security testing, DAST approaches since the early stages of an SDLC. While SAST helps analyze source code vulnerabilities before compiling the code and ensuring developers mitigate security flaws with real-time feedback, DAST helps identify architectural and code-level weaknesses while running in staging environments and/or production. We recommend implementing DAST scanner directly into your DevOps cycle. With continuous security checks, you can ensure vulnerabilities are remediated before ever reaching your customers. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.